Good morning, everyone. I hope you all are doing well. Today, we'll start with very simple topic that is dioxygen, that is O2. How we can prepare oxygen in lab, either by salts such as chlorates or nitrates, or either by decomposition of metal oxides. So first we'll deal with chlorates. For example, I have taken here example of potassium chlorate with formula KClO3. When it decomposes in the presence of manganese dioxide, it will break down to give you potassium chloride plus oxygen. So this oxygen we can used anywhere where it is required. Second, by thermal decomposition of metallic oxides like silver oxide and mercurous oxide. They decomposes to give you metal along with oxygen. So this much is all about oxygen. So you know its properties. It's a highly reactive. It can easily react with any substance. So we'll not do much about oxygen. Our next topic is ozone, that is O3. Ozone is an allotropic form of oxygen. How it's formed: oxygen when combined with ultraviolet radiations in atmosphere, it give us ozone. And how its laboratory preparation is: the ozone is prepared in specially designed apparatus which is called as ozonizer, and through which electric discharge is passed and highly energy is absorbed, that is of about 142 kilojoule per mole. That's why it is an endothermic reaction. You can see here I have written reaction: oxygen on passing electric discharge, it will give us ozone. What's the purpose of passing this silent electric discharge? That is also called as sparkless electric discharge. It's necessary to produce less heat, otherwise ozone decomposes back to give us oxygen. That's why it's necessary to give silent electric discharge, means slow electric current will pass through oxygen to give ozone. Now move to their properties, physical and chemical properties. First one is ozone is a pale blue gas which having very unpleasant smell, and it's heavier than air. It's slightly soluble in water but is readily soluble in carbon tetrachloride and glacial acetic acid. These are general properties. Now this one is oxidizing nature. It's a very important property of ozone. Why it act as oxidizing agent, or why it's showing oxidizing nature? Because it's now in previous reaction we have seen that it is highly endothermic process. It means it has absorbed energy, so it can releases its energy to decompose and give oxygen, and this atomic oxygen, which is also called as nascent oxygen because it's written in square bracket. So in chemistry terminology, this square bracket means nascent, and the atom which is present inside, like oxygen is present, so we'll call it as nascent oxygen. So because of releasing of this nascent oxygen, this ozone act as oxidizing agent. Now it can oxidize nitrites to nitrates, iodine to iodic acid, potassium iodide to iodine, lead sulfide to lead sulfate, and so on. So first is when it decomposes, it's give us oxygen and nascent oxygen. So potassium nitrite, this KNO2 is potassium nitrite. When combined with this nascent oxygen, now oxygen combines here and will get potassium nitrate. We'll combine these two reactions, these nascent oxygen will cancel out with one another, and will combine these two reactions to give us potassium nitrate plus ozone plus potassium nitrate plus oxygen. So this one is nitrite plus ozone to give us potassium nitrate plus oxygen. Second is, again I have written this reaction. It's up to you. You can write reaction in 3 steps, or either you can directly learn these overall reaction. It all also it depends upon you people. So second, I have written iodine when combined with the nascent oxygen in the presence of water to give us iodic acid with formula HiO3. And again I have combined these two steps by cancelling out this 5 nascent oxygen with one another. Third is potassium iodide when combined with nascent oxygen in the presence of water. It will give us potassium hydroxide plus iodine. So this we have done potassium iodide to iodine. Potassium iodide releases its iodine in the presence of ozone. Similarly, lead sulfide when combined with the nascent oxygen, it gives us lead sulfate. So overall reaction is lead sulfide plus oxygen to give us lead sulfate plus oxygen. Sorry, I think I have spoken wrong. Lead sulfide plus ozone to give us lead sulfate plus oxygen. So this much is all about ozone. Now again, it's very simple topic. We have done so many time in our junior classes, that depletion of ozone layer. Ozone is present in upper atmosphere in the form of ozone blanket, and that is called as ozonosphere. What's the purpose of this ozonosphere? It prevents harmful UV radiations from reaching our earth, because these are very harmful. So this ozone, it act as a blanket, it act as a shield, and suppose solar radiations they are passing, so it act as a barrier, so UV radiations are not coming to earth. But we are depleting it. How? Nitrogen oxides, which are emitted from exhaust systems of supersonic jet aeroplanes or rockets, might be slowly depleting the concentration of ozone layer. They convert ozone to oxygen, mainly nitrogen oxide. It combined with ozone to give us nitrogen dioxide with oxygen, means ultimately nitrogen oxide depleted ozone to oxygen. Similarly, ODS means ozone depleting substances like CFS, which is also called as chlorofluorocarbons or freons, which mainly we are using in aerosol sprays like your perfumes, like your deos, and as refrigerants, and also in ACs. So they're depleting ozone to oxygen. Same way, these chlorofluorocarbons, they are releasing chloride free radical. When combined with ozone, it will give us ClO free radical, that is chloro oxide free radical with oxygen. Then again this reaction will proceed and will get chlorine free radical. This chlorine free radical, when combined with another free radical of chlorine, it will give us chlorine gas with oxygen gas. So ultimately ozone depleting to oxygen, and that's why it's the formation of it's a main reason for the formation of this ozone hole. And because of this ozone hole, UV radiations, they are coming to earth, and it causes many type of diseases, including skin diseases, eye irritation, nose irritation, etc. So I hope it's clear to everyone. Thank you.